The next shape in our library of functions is the square function. So our equation is f of x equals x squared. So the idea is if we input an x value, to get the output, we just square it. So it's the square function. So here is the parent function f of x equals x squared. So we know that an x squared function makes a parabola, if you recall that from a previous algebra class. So the shape is a parabola. In this case, the coefficient of the x squared is positive, so we know the parabola is going to open up. And we can see it has a vertex of 0, 0. And if you plugged in a 0 for x here, 0 squared would get you out a 0, so you know it goes through the origin. Our domain is negative infinity to infinity. Our range, the lowest point, the vertex of the parabola is 0, 0. So our range is going to go from 0 all the way up to infinity. So we include bracket 0, comma, infinity. We can observe symmetry with respect to the y-axis, so that tells us this is an even function. Now, if we put our pencil all the way left on the graph and start to trace, we see we're falling, so we're decreasing. And actually, I'll trace it here. We're decreasing until we hit this vertex. And then we turn around and we start to rise and we're increasing. So I've got a down arrow from negative infinity to 0. So it's decreasing from negative infinity to 0. And then once we hit 0 to infinity, it's increasing. So it's increasing from 0 to infinity. Next is the cube function. So our equation is f of x equals x cubed. So here's our cube function, f of x equals x cubed. So this shape, some of my students have called this a snake shape or a squiggle shape. The book in my math lab calls it an increasing shape because everywhere you go on this graph, it's rising, it never turns around and comes back down. So as far as the shape, we can say like a snake shape. Obviously none of these are formal mathematical terms, just descriptors. So a snake or a squiggle or an increasing curve. So we can see our domain and range are both all real numbers, negative infinity to infinity. We can observe symmetry with respect to the origin, rotational symmetry. If we rotated the paper 180 degrees, we'd be back on the same shape. So that tells us this is an odd function. And as we just discussed, anywhere we trace, so if I put my pencil all the way left, anywhere we trace as we're moving left to right, it's always increasing. So it's going to be increasing from negative infinity to infinity, and it's never decreasing. Next is the square root function. So you've also seen this in previous courses. So it's the form f of x equals square root of x. So here is a sketch of our square root of x graph. So notice that this graph starts at 0, 0. And if you recall, that's because if we substitute an x value in and took the square root of a negative number, that's an imaginary number. That's not a real number. So this graph doesn't start until you put a 0 in for the x. So square root of 0 is 0. So that gives us 0, 0. And then all these positive values, because you can do the square root of positives, but you can't do square root of negatives without getting an imaginary. So our shape here, again, some of my students have called this a launch or a ray. Ray meaning it has like one end point and an arrow on the end. And actually, where the shape comes from, it's actually the top half. If you drew a parabola sideways, it's the top half of a sideways parabola is what that shape is as well. Okay, so our domain, we can see we start at an x value of 0 and we go to infinity. So we go from 0 to infinity. Same with the range. The lowest y value is 0, and it goes, again, this is pretty flat here for the first few x values, but this keeps getting higher and higher as you go out bigger x values. So our range is also 0 to infinity. No symmetry here, so this is neither even nor odd. And if we trace left to right, everywhere we go, this graph is increasing. So everywhere it exists, it's increasing. So it's going to be increasing from 0 to infinity, and it's never decreasing. Our cube root function, that's the form f of x equals cube root of x. Again, you also have a little experience with this from previous courses. So the shape of this, again, my students have called this an S shape or a sideways snake shape. So sideways snake or an S shape. So the domain we can see is all real numbers, negative infinity to infinity. Same with the range. We can observe symmetry with respect to the origin, that rotational symmetry, so this is an odd function. And here, if we trace from left to right, everywhere we go, this graph is rising. So everywhere we go, it's increasing. So from negative infinity to infinity, it's increasing, and it's never decreasing.